Hi guys, this video is on combining rational expressions, like a couple of the examples that you saw in the Desmos exploration. So I'm going to take you through a few of these problems step by step. And basically what you're trying to do is when you have a function that's a rational expression that you can look at the function and decide what the transformation and therefore what the vertical and horizontal asymptote is, how to take that expression and combine it into one fraction, because that's where we're going to be looking at trying to figure out the asymptotes when it is not a transformation of a function. It's just written as one fraction. So you're going to need to be able to combine these. So you're starting with a function that is 1 over x minus 3. So that x minus 3 tells me that the asymptote, the vertical asymptote is moved 3 units to the right, evil inside. And that plus 5 tells me that the horizontal asymptote is moved 5 units upward. So there's a vertical asymptote at x equals 3 and a horizontal asymptote at y is equal to 5. But what I want to be able to do is combine these fractions because, like I said, we will get to a point where we're able to tell what the asymptotes are from just one fraction. And so we want to know how to transform those back and forth. So just like adding any fractions, you need to have a common denominator. So what I'm going to do is give myself a common denominator of x minus 3, which is, so this is 5 over 1. And obviously the first fraction has a denominator of x over 3. So I want this fraction, the 5 over 1, to have a denominator of x minus 3 as well. So the reason why I need to multiply top and bottom is because whatever you're doing to change this 5 over 1, whatever I do to the denominator, I also have to do to the numerator, so that I'm essentially multiplying by 1 and not changing the fraction. So then my first fraction is not going to change because that already had a denominator of x minus 3. And my second fraction is going to turn into 5 times the quantity. I'm going to write this in parentheses so you don't forget to distribute. X minus 3 over x minus 3. 1 times x minus 3, which doesn't change. So since these now have the same denominator, x minus 3 and x minus 3, that means this can be combined into one fraction with the denominator of x minus 3. And the numerator is just those numerators added together. And in the next step, I can simplify that all. So that's equal to, again, one fraction all over x minus 3. 1 plus, and this 5, I'm going to distribute both to the x and to the negative 3. So 1 plus 5x minus 15. And in your last step here, all you have to do is combine any like terms. I only have the 5x term, and then 1 minus 15 is minus 14 over x minus 3. So that's how I take a function with two terms, as I have here in the example, 1 over x minus 3 and 5, and turn it into a fraction that only has one term. So these two functions are equivalent to each other. These are both equal to f of x. And you can confirm that this is the case, that you've done this correctly, by graphing the original f of x here and the one that you just got when you simplified all the way down. If it produces the same graph and the same table of values, you know that you've done it correctly. Okay, so I'm going to do the same thing in another example. So this is the function f of x is equal to 2 over x minus 1. So that means a horizontal asymptote at x is equal to 1 plus 3. And so again, this is really just 3 over 1, and I want the denominator to also say x minus 1. So I'm going to multiply top and bottom by x minus 1. And that's going to give me 2 over x minus 1 doesn't change, plus 3 times the quantity x minus 1 over x minus 1. So don't go cancel happy and now cross out these x minus 1s because you'll just go right back to the original step. Remember, the point is to make this into one fraction with a denominator of x minus 1. So now that my denominators are the same, like you see here, I can combine the numerators. So 2 plus 3 times the quantity x minus 1. And in your last step, all you have to do is distribute this 3 to both terms and get 2 plus 3x minus 3 over x minus 1. And then there's only a 3x, and now 2 minus 3 is negative 1, all over x minus 1. And again, I know you see some things that are the same. You might recognize that there's a negative 1 in the numerator and in the denominator, and you might be tempted to cancel that out. But remember that these are quantities. This is the quantity 3x minus 1 over the quantity x minus 1. And if you're a little bit unsure about those rules, again, a great check for you would be to take your original f of x, graph it on Desmos or on your graphing calculator, and then graph your final answer. And if you thought that something canceled, graph the part that you canceled, and you'll see that you don't produce the same graph. So these two functions in blue are equivalent to each other, and that will help you to determine your final answer. Okay, so in this last equation, there's nothing too much different. The only thing that's really changing here is not really what we're focusing on in this video. What's changing is what the horizontal asymptote is, which is going to be not a whole number. It's going to be negative 1/2 in this case, the vertical asymptote rather. But we're just focusing in this video on combining the fractions. So this is negative 3 over 2x plus 1 minus 1. And just like before, if you have just a numerical term at the end, this is really 1 over 1. And you want to create a common denominator, which is going to have to be 2x plus 1 so I can combine these fractions. So multiply by 2x plus 1 over 2x plus 1. That way, you're able to have the same denominator. So my first term stays the same, negative 3 over 2x plus 1 minus 1 times 2x plus 1. So that's not going to change, but we are going to be super careful with that minus sign over 2x plus 1. And that's equal to, you're going to distribute, well, first we're going to combine them into one fraction. So I'm going to get this question in class, I'm assuming, because I've gotten this question before when I teach this. And that question is often, a very common question is, why don't you distribute the number into the numerator before and then combine the fraction later? If you are careful, you can absolutely do that. But I do notice that when kids do that, they forget to distribute this negative to all the terms and make a mistake. So it's better to combine it into one fraction before you do this distribution step that I'm going to do here. You're less likely to make a mistake. So I would get negative 3 minus 2x minus 1 over 2x plus 1. Combine all your like terms, and you'll get negative 2x minus 4 over 2x plus 1. And so then again, to double check to say that you've done the math correctly, you can always graph your final answer and your original function that you were given and see if they produce the same graph in the same table of values. If they do that, you know you've done the problem correctly. Okay, I hope this was helpful to you. I'll see you guys in class.